Well, hello there guys, Mr. G here. This is going to be a video for lesson 9. It's going to be related to collisions. Is the last, let's say, content regarding momentum and impulse. After this one, we're just going to have the experiment, if possible, to prove the law of conservation of linear momentum, and then some questions to practice, and that's it. So this first topic of grade 12 is done. Thank you for watching along the whole topic from lesson 1 to the last lesson. Thank you for watching. I hope it helped you, which is the most important part. Please write comments, subscribe for the channel for the upcoming videos. I'm still deciding if must I make project 10, which is grade 12, or must I move to other grades. You can suggest if you want, but thank you for watching. Watch the video with collisions. We're going to classify collision as the two different type of collision they are. Thank you. I'll see you next time. Mr. G here.
Well, hello guys, Mr. G here, and we're going to be doing lesson 9. Now, lesson 9 is going to be related to collision. That is the topic. It's going to be collisions, and this is going to be the last topic of the momentum and impulse, the last lesson in terms of content. Then we're going to be making another one for just revision, practicing some questions related to everything we've done, but this is the last content we're going to be doing about momentum. Okay, and the first thing we're going to be doing is defining collision in physics. Now, collisions are isolated events in which two or more moving objects exert forces on each other for a relatively short time. So two or more objects interact with each other and they want to exert forces on each other, and the time of interaction is relatively short. That is what we call in physics collisions. Now, we can divide collisions in two parts. Now, collisions can be divided in two groups, let's say. So collisions could be either elastic or inelastic. Now, collisions can be elastic or inelastic. Okay. Now, when a collision is going to be elastic. Now, a collision is going to be elastic when both momentum and kinetic energy are conserved. So we said that elastic collision is when momentum and kinetic energy are both of them conserved. Now, when a collision is going to be inelastic, a collision is going to be inelastic when only momentum is conserved. So kinetic energy is not going to be conserved here. So we can say then that in a elastic collision, here in an elastic collision, we can say that the change in total kinetic energy is going to be equal to 0. It will not change. And we can also say that the change in total linear momentum is also going to be equal to 0. But in the inelastic collision, only momentum will not change. So total momentum or change of total momentum will be equal to 0. This won't happen to kinetic energy. Okay, so this is about collisions. Now let's explain this one with an example. For example, let's say we have two balls, and those balls are moving towards each other, and they collide, and these are going to be two billiard balls, two pool balls, the ones that they use to play pool. Okay, so now those balls are going to be moving towards each other. So let's say, for instance, we have this situation where two balls are moving towards each other, as you can see there before. They collide with each other, and they moving away from each other. Okay, unless let's say that this system is isolated. Let's say this system is isolated. So because momentum is always conserved, then we can apply the law of conservation of momentum. Okay, and now what states that law? That law states that in an isolated system, the total change in momentum is equal to 0. So it means that momentum is going to be conserved or is constant. So the total change in momentum is equal to 0, and if we break this one, we have in that the initial momentum is equal to the total final momentum. For these two balls that are moving towards each other, we have that momentum initial of ball 1 plus momentum initial of ball 2 is equal to a final momentum of ball 1 plus the final momentum of ball 2. So this is what we have, and obviously it can go further on to the substitution of the formula of momentum for each ball. For example, the mass multiplied by the initial velocity of the first ball plus the mass multiplied by the initial velocity of the second ball is equal to the mass multiplied by the final velocity of ball 1 plus the mass multiplied by the final velocity of the second ball. So this is conserved. You can apply this one for these two balls, but because the collision is going to be elastic, that we didn't mention here, we just explained one example. Because this collision is an elastic collision, then we said also that kinetic energy is conserved. Total kinetic energy is also conserved. And if we apply the same here, that means that the change in total or in kinetic energy, we're talking about total, change in total kinetic energy is equal to 0. That is not the kinetic energy of any of the two balls. It's the total kinetic energy of both balls before and after. So we can say then that the kinetic energy total initial is equal to the kinetic energy total final. And if we apply that, because we have two balls, we could have more than two balls, because we have two, is the kinetic energy initial of ball 1 plus the kinetic energy initial of ball 2, and will be equal to the kinetic energy final of ball 1 plus the kinetic energy final of ball 2. Is similar to the law of conservation of momentum. This is not the law, this is just that the kinetic energy is conserved. Okay, and if we recall from previous grades, we know that kinetic energy is equal to half the product of mass and speed to the power 2. Now remember, this is a scalar quantity, so we are not going to use the symbol of vectors. And then you can substitute that formula here, and then we'll have that half multiplied by the mass 1 multiplied by speed 1 to the power 2 plus half mass 2 multiplied by the speed of the object 2, in this case is the second ball, to the power 2 is equal to half mass 1 multiplied by the final speed of object 1 to the power 2 plus half multiplied by mass final speed of object 2 to the power 2. So in other words, if you want to identify a collision as elastic or inelastic, all you have to do is to use the conservation of kinetic energy. If the total kinetic energy initial is equal to the total kinetic energy final, that means that kinetic energy is being conserved, and therefore the collision is going to be elastic. This only happens in an elastic collision. If the collision is inelastic, only momentum is conserved but not kinetic energy. And this is pretty much everything, but let's use one example, an actual example, where we are going to give values to these masses and prove that they are conserved. Okay, so here we are with one example. This example, we're going to use the same balls, say 2 billiard balls, each with a mass of 150 grams. So let's write the data quickly here. Mass 1 is equal to 150 grams, and obvious mass 2 is also equal to 150 grams. When you convert, this will be equal to 0.15 kilograms and equal to 0.15 kilogram. That is the mass of each ball. Collides head on in a collision. Ball 1 was traveling at the speed of 2 meters per second and ball 2 at the speed of 1.5 meters per second. That is before the collision. After the collision, ball 1 is traveling away from ball 2 at a velocity of 1.5 meters per second. Identify the type of collision. So as usual, let's first of all write the data, and we already did write the mass. So let's write the velocity right now. Okay, for velocity initial of the first ball is going to be 2 meters per second, and the initial velocity of ball 2 is going to be equal to 1.5 meters per second. Right, now we have one that is moving in one direction and the other one is moving in the opposite direction. Okay, so let's finish the data first. So after the collision, what we have is that ball 1 travels away. So the final velocity of ball 1 is going to be equal to 1.5 meters per second, and we don't know the final velocity. We don't know the final velocity of ball 2. However, they ask us to identify the type of collision. Now, to identify the type of collision, we need to use the conservation of kinetic energy, because momentum is conserved in both. So momentum won't help us to identify the type of collision. Only kinetic energy can. So if we calculate the total kinetic energy initial and the total kinetic energy final, and they are equal, then we can say that the collision is elastic. But to do that, we need the final speed of the second ball. And to calculate the final speed of the second ball, we need to calculate using momentum. Why? Because momentum is always conserved. It does not matter what type of collision are we talking about. Okay, so now before we solve that one, let's identify the direction that we want as positive. And to do that one, they're speaking about forward and backward. So what I'm going to do is I'm going to do this arrow here, and that direction in the arrow is going to be positive for me. Remember, this is up to you guys. Nobody tell you what direction must be positive or negative. That is entirely up to you. So let's use momentum, conservation of momentum, which we did a lot of questions about that. You can watch the videos to calculate the final speed, and then conservation of kinetic energy. So I will move forward, but I will show you how to arrive to that velocity. And here at the end, using the law of conservation of momentum, which we did previously a lot, we get that the final velocity of the second ball is 2 meters per second. We didn't have the final speed, final velocity of the second object, but we need it. So we applied the law of conservation of momentum, which we explained many times. In this case, we select that direction, let's say to the right, as positive, and everything to the left is negative. Here in the ball, you can see that ball 2 is moving to the left, and that's why it's negative. In the substitution, I highlighted that. Now, we have this one. What we're going to do is to apply the conservation of kinetic energy. We're going to calculate the total kinetic energy initial and the total kinetic energy final. And if the total kinetic energy initial is equal to the total kinetic energy final, then we said that the system or the collision is going to be an elastic collision. So here's the substitution of the total kinetic energy initial. We already did write that one top there, so you can watch it. And then if we substitute, we have. So that is the total kinetic energy initial. And let's now calculate the total kinetic energy final. So we have to answer the question now. The question is identify the type of collision. So the type of collision is going to be elastic. So we have to write, therefore, the total kinetic energy initial is equal to the total kinetic energy final. This is important. Collision is elastic. And that is how we solve these questions on collisions. Now, in an inelastic collision, then kinetic energy is not conserved, so you cannot use kinetic energy in that situation. However, to identify, you can always use it, and then you come to the final conclusion. If the total kinetic energy is equal to the total kinetic energy after the collision, then we can say that the collision is elastic. If they are different, there is inelastic. So guys, this is all for collision. I hope you understand. It's quite easy. It's the final lesson on this topic. However, we are still going to make the experiment to prove the law of conservation of momentum, if possible, and then we're going to do 1 or 2 videos of revision, and this topic is finished. Okay, thank you for watching. Subscribe, like the video, ask questions, and I'll see you next time. Mr. G here.